Okay, so Assalamu alaikum everyone. I hope that the screen is in front of you and you are able to see it. I don't think that you're able to see it. Yeah, okay. So you'll be able to see it now. Okay, so here we are with a tutorial on LTSpice and we hope to make things easier for you in the course because of this tutorial, because some of you are perhaps facing problems with this tool. So to begin with, uh, how to open up LTSpice with a new schematic, you go on File and you click New Schematic and it opens up. I've opened up one for you already, which is for the tutorial's purpose. Then you go on to put up components, and that is how you can open up the components list in front of you, where you can search up anything like a resistor, an inductor, capacitor, a MOSFET, anything that you're looking for, a power supply maybe. Yeah, so that's a voltage source. That's how you search it here. Yeah. So all of this can help you find the components and you can put them up like that. Well, once you're done with putting them up, you can simply press the escape button and you get rid of it. Then there are some very basic, like the resistor, capacitor, inductor, diode components, which are easily available in this menu. And you can rotate them using the Control R option. So you would probably not be able to see, but I'm pressing the control key with R on my laptop, and it allows you to rotate it at 90 degrees. Using Control E, you can reflect the component if that helps. Uh, and you can place it like that and just make a very basic circuit for your ease. Once you're done with using it, you can just press the escape button and you're done. You're good to go. Then you can connect your components using wires, because like that's what a complete circuit really is. You have the wire option button on the same menu, and you can select that to make a wire, and you can click once on the point where you wish to bend it. Once you're done drawing the wires, you can just press the escape button. Another way to draw wires is to right click, go on the draft option, and then click on the draw wire option, and that's how you'd get a wire, and then click on the point for once where you wish to uh, bend the wire. And then one other option to draw a wire, which you would have seen, is the F3 option that you can click and you'd be able to draw a wire for your circuit. Okay, so we have a complete circuit in front of us. I can press the escape key and get rid of the wire. If I wish to, for instance, delete something, I just simply need to either choose the scissor option that allows me to cut it from here. Another option is to click on that very component and then press the delete button on your laptop. It will give you the scissor option again, which is to cut it, and you'll have it figured out. So yeah. And now I will have to put up the components again. So that's what I'm about to. Control R, putting it up here for your ease, and escape, and then drawing wires to connect my circuit. Okay, we're back on the same point now. There's one thing that's missing, which I will give you a second to think about, that what is it that we're missing in the circuit, without which our circuit the simulation won't run and it would give me an error. So what is it? Yes, okay. I sound like Dora the Explorer right now, but like, yeah, that's the ground. Okay, So now you would connect the ground with the circuit like that. And now we're good to go. That's a complete circuit which is in front of us. But we're still not done with assigning values. So let's go on to assign values. I would first need to do it for my voltage source. Okay, so what I simply did was that I went over the voltage source, right clicked it, and I have it open in front of me where it wants me to give it a DC value. So let's just choose perhaps, I don't know, 12. Yeah, 12 volts. I'm not giving any series resistance and it would function fine without it. Okay, so similarly, I would do it for the resistor. Maybe, I don't know, 4 volts, 4 ohms would be fine. You can even go on to give the tolerance and the power rating, but that's not something which is needed as of now. So I'm not putting it in. And then maybe 6 ohms or perhaps 8 ohms. Okay, so yeah, we have a very basic circuit in front of us, which wouldn't function like that. There's still something that is missing, and that is this. You need to give the spice directives, without which your circuit won't function. And for a simple DC circuit, you just need to write .op and you need to place it here. So that's how it would start working. Another way to go about it is to just click it here, and then you could add that. Could have added it here as well, but I did it from there. So that's how you go about it. And then you have this picture of a man running, which is the way to go about running a simulation in LTSpice. And clicking that will run this for you and give you the current through R1, the current through R2, and then you will also have voltages. So that's how you go about it. And definitely the current through the voltage source, which is V1 as well, which is the same because we have a series circuit and you have a total resistance and a total voltage and voltages across the resistors because voltage divides in the series. So that's basic. That you can even give a sanity check through this window, which I hope is visible to you, but I'll check. I don't think it's visible to you. I hope now it's visible to you. So this is what opened up, and yeah, so this is what just comes up. And then yeah, so this is basically it. That's more about it. And also there's one more thing that might be helpful for you, and that is the idea. I'm not sure if it's still okay. So yeah, okay. So one more thing is to be able to measure voltages at a specific point, and you can do that by clicking on a very specific point, and it will give you the voltage with respect to ground. That you have a power supply here, right? So it's 12 volts, and this is a sanity check that yes, you have 12 volts here. Then you have a voltage drop across R1, leaving you with 8 volts across R2, and you have 0 volts on ground. So just clicking on those points of wire will allow you to have a look at the voltages at that very point. Okay, so this is all for a very basic circuit. Now moving on to an example that I've already prepared for you is that of a complex circuit where you have PMOS and NMOS connected and a complete circuit which you will be learning towards the end of this course on how to make such circuits. You would have been aware that whenever you're using PMOSs and NMOS, you need to give its parameters, which you can see from the dot model test NMOS and dot model test PPMOS with the parameters given, uh, where you have the lambda and the threshold voltages and everything defined. So this is an example of a circuit which I will show how you can run the simulation and see that what are the waveforms at different points in the circuit and verify if things are working fine. Which is why we give you questions even in the assignment where you are to do some hand calculations and then verify your results. So running this circuit, I think I can close this one. So right, we can run this circuit, and now you have a window open in front of you that will give you waveforms of different points where I'll be clicking on. So if I need to verify, for instance, that I'm measuring something over here where I have a 1.8 VDD, so you can see that yes, I have the voltage waveform, which is exactly that, all across time. So even at other points in the circuit, I can go on to probe and see what the voltage turns out to be. And that's how it should work. So yeah, this is the gate voltage and this is pretty much expected. You can go on to measure voltages at different points in the circuit, and you will see that you will be making use of what the simulation tool really has to offer. So yes, that's about it, and I hope that this clarified stuff for you. Feel free to ask any more questions that you may have. I'd be happy to answer them, and good luck.